Good morning. It's Friday, February 6th. I have a meeting this hour, so I just found out about. So I will see if I can help you with the limiting reactants worksheet that is on my big campus. I will also have some soft copies ready for you, or hard copies ready for you if you'd rather do this math on regular paper. So let's go ahead and do number 2 today. Mostly because number 1 has a really fun equation that takes a little challenge to balance, and I don't want you to give up. I want you to keep trying. But we'll check it on Monday. Number 2. So first of all, this is a stoichiometry problem. How do we know? Stoichiometry is a quantitative relationship between reactants and products. So the key is that it is a reaction. So if you look on the board above the board in the front of the room, there are 4 steps to stoichiometry. The first one is to write a balanced equation. So please pause this video and go ahead and attempt letter A. All right, let's see how you did. This is a synthesis reaction. It looks like we're taking potassium and we are reacting it with sulfur. So this one should be easy to balance, in my opinion. Potassium is a +1, sulfur is a -2. Therefore, we would need 2 potassium ions to balance with the 1 -2 sulfur ion, balance the total equation, and that is 2 potassiums for every 1 sulfur produces 1 potassium sulfide. In this story, in the question, they give us 2 numbers. So that reminds you that you're going to have to do 2 stoichiometry problems to get to the answer. So, which reactant is an excess? So we're going to try to figure out which one's the limiting reactant and which one is the excess reactant. In order to do that, we need to do some stoichiometry. According to the chart, step 2, convert to moles. So I'm going to set up my equation with 4 sig digs. And because there are 2 numbers, I get to do twice as much fun. So let's go ahead and pause and see if you can convert, according to the sign, convert to 20 grams of potassium to moles. To go from grams to moles, we need to molar mass. We need to know the molar mass of 1 mole of potassium. In this case, according to the periodic table, it is 39.1. We have now converted to moles. If we were to quit right now, we'd be at moles of potassium. Stoichiometry says that for every 2 moles of potassium, I'm only going to produce 1 mole of potassium sulfide. So for every 2 moles of potassium, that is 1 mole of potassium sulfide. If I were to cancel right now, I would be at moles of the product. Notice that I have just crossed the bridge if you were comparing this to the stoichiometry fairy tale. I am now on the side of the unknown. I'm happy, everything's good, except for I'm a mole. The story says right in, it doesn't really tell us what we want to do. I, based on experience, usually know that sometime they're going to ask for the final mass. So I just assumed that. I should have looked ahead. But that is where we are headed, the mass of potassium sulfide. So for every 1 mole of potassium sulfide, I need to molar mass that. Pause the video, molar mass potassium sulfide, plug it in your calculator, and see what you get. The molar mass of potassium sulfide is determined to be 110.3. Plug that into your calculator, and you should get, with 4 sig digs, 28. Actually, I have not plugged it in my calculator. If you would go ahead and do that for me. I know the answer is 28.2, but I did not have the right number of sig figs, so go ahead and round that to the 4th, to the 100th place. Pause this video and attempt the entire part for sulfur. So, I have molar massed sulfur. I know that 1 mole of sulfur is 32.1 gram. In this case, it is a 1-to-1 mole ratio. For every 1 mole of sulfur, there is 1 mole of potassium sulfide. And because I'm going to the same destination, I can kind of peek up here and look at the molar mass of potassium sulfide. I'm going to plug this in my calculator, and once again, I have the wrong number of significant digits, so if you would take that to 1 more point. I have 2 possible answers. Just like in making s'mores, once you run out of one of the reactants, the reaction stops. This is impossible because as soon as I made my 28.2 grams of potassium sulfide, I have run out of potassium. Potassium is my limiting reactant. They're not asking me that, but they are asking me which reactant is in excess. And in this case, it would be sulfur. So go ahead and attempt number 1 and 3. If you wouldn't mind putting a answer on the board, I would appreciate that. And we will see you on Monday. Good luck.